This hearing will come to an order, and good morning, everyone. Welcome to the committee's third hearing on the Intergovernmental Panel on Climate Change, fourth assessment report. On May the 4th, the third working group released a summary of its chapters on the mitigation of climate change in Bangkok. The summaries of the working group 1 and 2 released earlier this year indicated that both adaptation and mitigation strategies are needed to counteract the effects of increasing greenhouse gas concentration in the atmosphere. Adaptation strategies can lessen the impact of the challenges in climate and changes in climate we are experiencing now and that we will experience under any scenario in the future. However, the IPCC report tells us that if we are to avoid the dangerous impacts of climate change associated with global temperature increases of 4 degrees or higher, we must develop and implement mitigation strategies. Working Groups 3 report outlines specific measures that we can consider to design a path to stabilize and then reduce greenhouse gas emissions. Some are policy measures, others are technological. Not surprising, the report counsels that the earlier we begin, the better chance we have of achieving the goal of avoiding dangerous impacts of climate change. Of course, we're all concerned about the cost of achieving this goal. As we all suspect, this effort will be costly, and the estimates of these costs vary considerably depending upon the assumption used in the economic models to generate them. However, inaction is not cost-free, either in monetary terms or in human suffering. Longer, more intense droughts, increased flooding, and accelerated sea level rise are all very costly. Increased public health problems and increased mitigation of environmental refugees are also very costly, as the Pentagon recently pointed out. While there will be costs, there will also be benefits and opportunities for new jobs and new industries. We simply cannot afford the cost of inaction, especially when we consider our need to move to a new generation future to achieve greater national and economic security. The summary does not point to any single policy or group of technologies that will achieve emission reductions. Each nation and each region must participate in a global effort to reduce emissions by developing strategies that will work within their respective economic and social frameworks. We must do for the U.S. the types of analysis performed by the IPCC for a global basis to understand the cost and benefits associated with alternative mitigation policies and technologies. Time is the one thing we can never recover. We have an opportunity, if we act now, to avoid radical alterations in our world that we will be unable to adapt to or to overcome. We have an obligation to our children and grandchildren to face the challenge of climate change and deliver them a future that is an energy secure as we inherited. We can only accomplish that by diversifying our energy supplies and becoming more energy efficient. We have the opportunity to lead the world in cooperative effort to make sustainable development not just a goal, but a reality. The sooner we begin, the better off we will be. We have a distinguished panel of witnesses here this morning to discuss the options of mitigating climate change. Welcome to all of you, and thank you for being here today to discuss this important topic with the committee. At this time, I'm pleased to yield to the distinguished ranking member, Mr. Hall, for an opening statement.
Thank you, Mr. Chairman. I'm really pleased that you're holding this hearing today because it provides all of us with an opportunity to discuss what I believe and others of us believe this committee should focus on when it comes to the issue of global climate change and how much it's going to cost and what do we get in return. The key question, I think, facing all of us here in Congress is not what does the latest science say about climate change. The key question is, given all the science, what is the appropriate policy for the United States to move our nation towards affordable, and I repeat again, affordable, reliable, and clean energy sources? It's not an easy question to answer. We have to consider if the U.S. regulates greenhouse gases, what impact could we have on other major carbon-emitting countries who do not follow suit? Would this reality put America in the position of shouldering the burden of cleaning up the world and having our citizens bear the high cost, what would regulations mean for the price of natural gas, for example, for electricity rates? Are these costs we're willing to accept if given the uncertainty about whether regulations could help them? Do you think we'd accept them? When I return to my congressional district, constituents have high on their list the high cost of gasoline. We need to be looking at ways to lower this cost, not raise it, and yet the scenarios being discussed today propose raising the price of gasoline substantially. Estimates of price increases range from 20 cents per gallon to as much as $1 per gallon. Rather than focusing on ways to raise energy prices for Americans, we ought to be discussing what the United States could accomplish with the right investments in energy research and in energy development. We have to consider the enormous benefits and the low cost of adaptation, and we must not lose sight of other pressing national priorities and understand the overall burden of all the national needs to the average citizen. Work Group 3 was asked to look at ways to mitigate greenhouse gases, and that's what they did. I think their charge was too narrow and should have included a more comprehensive assessment to help us answer the questions I mentioned earlier. Policymakers should not make decisions in a vacuum, and so it would be more useful if the technical information presented to us was placed in a broader context. Nevertheless, they did what they did under the charge that they were given. The Working Group 3 report points out that even a middle-of-the-road greenhouse gas mitigation approach would mean a reduction of up to 4% of global GDP. Global GDP. Let me place that in context for you. At the end of the first quarter of 2007, the U.S. GDP was $13.6 trillion. 4% of that is $544 billion. Now remember that figure, $544 billion. By comparison, total United States spending on defense in FY 2004 was $567 billion, just a little bit over the 4% that I'm asking you to compare with. The American Competitiveness Initiative, when complete in FY 2016, will total only $19 billion, just a fraction of 1% of the U.S. GDP. $143 billion is the total federal R&D investment in FY 2007. Nationwide education spending, federal, state, and local combined, as a percent of GDP, is 5.7%. Finally, the entire budget for the Social Security Administration is on the order of $600 billion. Compare those, and what do you think of those comparisons? Mr. Chairman, now that all three groups of the IPCC have reported, I look forward to the real discussion the committee should promote. We should be the leader in the House of Representatives for promoting wise investments in energy research and development, investments that tap into America's innovative spirit and lead us to a future where our energy supply is affordable, reliable, and clean, and I add again, affordable. I'll yield back the balance of my time.
Thank you, Mr. Hall, and I just want to remind you that out of the subcommittee this week we passed the ARPA-E bill. We'll have an opportunity to carry out your wishes next week when the ARPA-E bill will be on, which will be the most cutting-edge effort to do that kind of technology investment at, as you pointed out, a very modest way. Yes, sir, Mr. Hall, did you?
I respect you and respect your position, and I look forward to next week.
Thank you, sir. And if there are members who wish to submit additional opening statements, your statements will be added to the record. And at this time, I would like to introduce our witnesses. First, Mr. Mark Levine served as the coordinating lead author for Chapter 6, Specific Mitigation Options in the Short and Medium Term, Residential and Commercial Sector of the Working Group 3 report. Currently, Mr. Levine works as the Division Director of the Environmental Energy Technology Division at Lawrence Berkeley Laboratory. Our next witness will be Dr. William Pizer. He served as the lead author for Chapter 11, Mitigation from a Cross-Sectoral Perspective of the Working Group 3 report. Dr. Pizer is a fellow at Resources for the Future and senior economist at the National Commission on Energy Policy. Mr. Stephen Plotkin served as the lead author of Chapter 5, of the report entitled Specific Mitigation Options in the Short and Medium Term, Transport and Infrastructure. Mr. Plotkin is a transportation energy analyst with the Center of Transportation Research at the Argonne National Laboratory. And finally, Mr. Roger Pilkey, Jr., is a professor of environmental studies program at the University of Colorado and director of the Center for Science and Technological Policy Research. As our witnesses should know, that we try to limit our spoken testimony to 5 minutes, but this is an important hearing, and we want you to be judicious, but to take what time you need. And we will start with Dr. Levine. Thank you for being here.
Thank you, Mr. Chairman, and distinguished members of the committee. I greatly appreciate your holding this hearing on this important topic. I'm honored to be here today to speak to you. As you pointed out, I am a senior staff excuse me. I'm a senior staff scientist at Lawrence Berkeley National Laboratory, former division director, but I speak to you in my capacity as coordinating lead author of Chapter 6 of Working Group 3 of the Fourth Assessment Report. I was asked to address two questions. The first was to describe to you the findings from Chapter 6, specific mitigations in the short and medium term for residential and commercial buildings, and second, to explain how these findings differ from previous assessments. I think this chapter is particularly interesting in light of the opening comments that we've heard, because buildings represent an opportunity to reduce, to mitigate carbon dioxide emissions cost effectively, so that in fact the concern that you may have about impacts on the economy need not be concerns if one does energy efficiency cost effectively, and there are numerous opportunities to do so in the building sector. The summary for policymakers notes that energy efficiency options for new and existing buildings should considerably reduce CO2 emissions with net economic benefits. It goes on to estimate that by 2030, one could achieve 30% reduction in emissions due to energy use associated with buildings if one were able to tap into all cost-effective measures. Of course, tapping into all these measures is no easy job, and the report points out the numerous barriers that exist to obtaining these measures in the marketplace. It also notes that it is particularly difficult for many developing countries to overcome the many barriers to energy efficiency in buildings. Let me make a few comments on the findings. There's several significant features of this report. The first is that the full report of 90 pages underwent extensive review by governments, by experts, and so I view the report as authoritative a review of the literature as one can find, far more than my colleagues and I could ever have accomplished. It's a long and torturous process at the IPCC, but it does give quality and works very hard to remove bias. My second comment has to do with the contribution of the report to reviewing the different bottom-up studies of energy efficiency potential in buildings. By bottom-up, I mean a characterization of the key technologies that can reduce carbon dioxide emissions, their cost, and the quantity of emission reductions that can be achieved through time. The analysis involved a review of 80 studies and a thorough assessment of 17 of these. These studies covered the globe. This is the first time that a thorough analysis of these types of studies have ever been done, and this analysis gives me confidence that we're working on a body of literature that is in fact meaningful. I've been troubled for many years working in the field, not knowing what really was understood out there in work carried out in many other countries. So this, I think, is a significant achievement. A second observation from the study is that this 30% reduction, if you could achieve it, is comparable to a 30% increase that would be projected in the lowest of the scenarios that we're looking at, and comparable to about a 45% increase in a typical scenario that we're looking at. So that it is within the realm of the possible that this cost-effective potential, a potential, Mr. Hall, that would not, for the case of buildings, cause damage to the economy, could be achieved without increasing emissions. But of course, it depends on the scenario itself, and those results would be less significant if the scenario is higher. On the other hand, it's important to note that 70% of electricity is used in buildings, and as we decarbonize electricity, that reduces emissions from buildings. Now there you get into carbon charges. If you want to decarbonize electricity, then it is likely that you will have to talk about certain carbon charges. Finally, I want to observe that notwithstanding these opportunities, the policies necessary to bring about these major reductions are very substantial. And the study identified many policies that were in fact quite effective in different places, but it did not identify any silver bullets, any policies that were effective broadly, but it did show quite a number of effective policies. Now, I've spent most of my time, I think. Let me conclude with your last question. How does this compare with the previous assessments? The third assessment report devoted very little attention to this topic, so I almost want to skip it, except that it came up with some estimates that said, well, we could in fact achieve emissions at 1998 levels in 2010, 2020, and 2050, but those were admittedly guesses of the team. And so we give them low evidence and low agreement in our terminology for how much how much credibility we want to place on those results. And that's about it for that report. In the second assessment report, there was a thorough description of technologies, a description of policies, but no evaluation. And the reason for that was that the world hadn't moved toward energy efficiency far enough at that point to be able to do evaluation. So I think my major conclusion is that the world's come a long way. There's really no contradiction among the assessments, but we've seen an evolution of knowledge over time as different countries, different regions, different cities have implemented different policies and different technologies for greenhouse gas mitigation in the building sector. Thank you very much.
Dr. Pizer?
Thank you, Mr. Chairman, for the opportunity to talk about the recent IPCC report. Let me just start by saying the summaries I'm going to give you here today are not necessarily reflecting the opinions of my colleagues at Resources for the Future, which is an organization that does research on environment, energy, and natural resource questions, but does not take positions on matters of public policy. It also does not necessarily reflect the opinions of all my co-authors. There were more than a dozen authors on my chapter of the IPCC, and the report reflects all those different perspectives, and I will be sharing some of my own personal views as I summarize the report. If I try to summarize the conclusions of the report about the costs of mitigation on the overall aggregate level, the way I think about it is the following. There are a variety of different stabilization targets we could think about over the next century, ranging from doing absolutely nothing and at the end of the century looking at somewhere between perhaps a 3 and 7.5 degrees Celsius increase in temperatures, or we could do something really aggressive and try to stabilize concentrations at almost current levels and have very rapid reductions in emissions. Now, obviously, the cost of doing nothing, if we ignore the environmental consequences that were mentioned earlier in terms of coastal impacts and ecosystems and health and food and things like that, if we ignore those sorts of impacts and we do nothing, the cost is going to be nothing. On the other hand, if we do something aggressive, like try to stabilize concentrations rapidly, try to avoid more than 2 degrees of warming globally, well, the report suggests that the cost could be perhaps as much as 3% of global income in the year 2030. And if we think about, well, how does why is it up to 3%? Well, the report actually doesn't have a lot of data on what the costs of stabilization are at these very low levels. There's a lot more data on things in the middle. And there the estimates range from something like a 0.6% increase, that is a net gain to the global economy, to somewhere up to about a 2.5% cost of income. If we compare these estimates to the last assessment report, as Dr. Levine just did, the main difference is that the new report suggests these very low and possibly negative costs, that is maybe a 0.6% gain to the global economy. And the reason for this is that the new report considers models, first of all, which incorporate more of the energy efficiency opportunities that Dr. Levine mentioned, and they also include the possibility that new energy technologies could have very broad economic benefits, things like the internet or mobile technologies that really advance overall economic growth. So if I look at these conclusions and I try to think about observations, there are really 4 that I'd like to make in my opening remarks. And they concern uncertainty, the need for public support for R&D, the need for or the importance of efficient global solutions, and last but not least, trying to put these into maybe a more accessible framework. So let me just quickly go through those. First of all, an uncertainty. An important thing to realize is this range of estimates that I just gave you does not have a probability associated with it. The cost could actually be higher or lower. And the reason is that this is a collection of best guesses. And if you think about, for example, your office basketball pool, most of the people bet on the top seeds, right? Well, in 8 of the last 29 championship games, someone other than the top 2 seeds have won. So what that means to me is when you look at a collection of best estimates, it's a good way to predict the likely outcome, but there's also a reasonable chance there's going to be something else happening. And in terms of thinking about policies to deal with climate change, it's very important to think about what's going to happen if our best pick does not end up being right. The second observation concerns technology. And I mentioned that the low-cost estimates that we've seen in the recent report hinge on energy efficiency opportunities as well as the opportunity for new technologies to lead to broad economic benefits. And one of the potential problems, for example, is that as we invest in these new technologies that have broad economic benefits, we may be taking away from other technologies that also have broad economic benefits. So to me, the lesson in the report is actually the need for broad public support of research and development, very much like the ARPA-E policy that's come out of this committee. The third observation I would make is that all the estimates in this report emphasize the need for broad, flexible global solutions. And to the extent we don't have those solutions, it's going to be more expensive. So to me, the lesson for public policy in the United States is to think about broad, flexible domestic policies and engagement with the rest of the world to try to get similar policies elsewhere. The last thing I want to mention is that if you want to try to make sense of these cost estimates, things like 2% of global income or something like that, I think a useful thing to do is to try to break it down to what it means for a household. If we think about what household income is likely to be in the year 2030, where a lot of these cost estimates focus, the median household is probably going to be around $55,000 per household. That is, half the households will be more wealthy and half will be poorer. If you take 0.5% of global income and apply it to that household, it would be about $275. And that's kind of the moderate approach to stabilization. If you take the more aggressive approach, it would be something more like $1,650. You could also turn that into prices. The more aggressive approaches, trying to limit warming to 2 degrees, would be something like $1 per gallon of gasoline, or maybe a several cents per kilowatt hour. The more moderate proposals would be something like 20 cents a gallon of gasoline and maybe 1 cent per kilowatt hour. So to me, if you're going to try to make a decision about what sorts of long-term stabilizations to go for, you have to look at these costs and weigh them against the benefits that we're getting. Somewhere in the middle, maybe a 2 to 5 degree likelihood of warming, or something more aggressive that would really limit warming to being less than 2 degrees. So in summary, I would just emphasize that the report has a range of estimates, and if we're thinking about policies, we need to think about policies that are going to be responsive to the unlikely outcomes that it's more or less expensive. We need to deal with the fact that technology is very expensive, and we can't just set a cap and trade in motion and go home. We're really going to need public support for R&D. Third, that we need to pursue broad and flexible domestic policies and engage the rest of the world. And last of all, to make some sort of choice about stabilization, we're going to need to come to grips with how much we want to reduce the risk of climate change and how much we're willing to spend. Thank you.
Mr. Chairman and members of the committee, thank you for this opportunity to discuss the IPCC's finding on mitigating greenhouse gas emissions from the transport sector. Transport is especially important because it represents nearly a quarter of energy-related greenhouse emissions, because it is growing rapidly, and because it is bound so tightly with oil. Oil supplies 95% of its fuel, and transport represents half of world oil use and about 2/3 of U.S. oil use. On their current path, world transport emissions and oil use will grow at about 2% per year. That means that by 2030, they will have grown by 80%, almost doubling. Although much of that growth will occur in the developing world, led by China, U.S. transport emissions and oil use are also expected to grow at nearly 2% per year. If conventional oil production cannot keep pace with this rapid growth, the most likely supplemental fuels would be liquid fuels from tar sands, heavy oil, coal, and natural gas. These supplements would tend to increase greenhouse emissions. Further, a transition to these fuels would probably not go smoothly, and supply disruptions and very high prices would be likely. This creates a strong added incentive to take steps to reduce the growth rate of transport's oil use. Much of the growth in transport emissions is driven by the rapid increase in ownership of personal vehicles, including two-wheel vehicles, in the developing world. Although much attention is focused on this growth, both freight transport and air transport deserve close attention also. Freight now accounts for over 1/3 of transport energy use and greenhouse emissions, and actually is growing more rapidly than passenger transport. And air travel accounts for 12% of emissions. It's got a 5% growth rate, which is the fastest of all modes. And its effects on climate change are magnified by airplane contrails and the cirrus cloud enhancement caused by the high altitude of aircraft emissions. Since the IPCC's third assessment report in 2001, there have been significant advances in efficiency technology. Direct injection diesel engines, 30% more efficient than gasoline engines, have over 50% of new car sales in Europe. These engines are much cleaner than older diesels, and their emissions performance continues to improve. Automakers also have made great strides in improving the performance and reducing the costs of hybrid electric vehicles, and their use is spreading. Their ultimate role, however, will depend on how successful automakers are at further reducing their costs. Finally, there has been steady progress in hydrogen fuel cell development, but further progress in reducing costs and increasing onboard hydrogen storage capability and strong government support is crucial to further commercialization, to future commercialization. Several potential improvements to new light-duty passenger vehicles, that's cars and light trucks, could conceivably double their fuel economy by 2030. These are briefly described in my written testimony, and let me give you an idea of the costs. We're talking about costs that are comparable to leather seats in a sunroof or four-wheel drive, a few $1,000s. The key issue is whether these technologies will be used for reducing fuel consumption or instead to increase performance and size. EPA estimates that increased weight and acceleration capability has cost the U.S. new car and light truck fleet's fuel economy over 5 miles per gallon between 1987 and 2005. That is, we can use this technology for fuel economy, or we can use this technology for other things. And although the U.S. may be an extreme case, this type of trade-off of performance and size versus fuel economy is being made throughout the world. And biofuels, but technologies exist to reduce greenhouse gases in other transport areas as well. For example, a combination of aerodynamic and engine improvements could increase the fuel economy of intercity freight trucks by as much as 50% when they're on the highway. And biofuels can play a substantial role in reducing greenhouse gas emissions from all transport modes, displacing as much as a quarter of oil-based fuels by 2050, but only if we make substantial progress in developing the technology for using materials such as switchgrass and wood waste. There is an array of potential policy tools to help reduce transport's greenhouse emissions. In areas with rapid urbanization and transport systems in the early stages of development, good urban design, development of efficient public transport systems, and promotion of walking and biking can reduce the number and use of personal vehicles while providing excellent mobility and access to services. These policies also have an important role to play in the United States and elsewhere in the industrial world, although obviously much of the die is cast in terms of our dependence on personal vehicles and in the form of our urban areas. Another key policy tool is to reduce greenhouse gas emissions from personal vehicles is the fuel economy standard. Standards are now being widely used even in countries with much higher fuel prices and vehicle taxes than ours. They have been effective in the past in the United States and elsewhere in slowing the growth of oil use and greenhouse emissions. Some form of fuel economy or CO2 standard or agreement is now in place in Japan, the European Union, China, Australia, and elsewhere. And the state of California and a group of other states are attempting to establish their own CO2 standards. Taxation policies on fuels and vehicles can also play an important role, and let me say that, yes, some of these policies may translate into a fairly high gasoline tax. However, we can recycle those taxes, we can reduce taxes elsewhere in the economy. If we do that intelligently, the effect on the economy does not have to be negative. Many countries do heavily tax motor fuels and have lower rates of fuel consumption than countries like ours with low taxes. However, vehicle travel demand, the demand for vehicles and fuel use are not highly price elastic. So relatively high taxes are required to have major effects on fuel use and greenhouse gas emissions. For the longer term, there are a number of technologies that could make a major difference in transport emissions, but all require significant advances that must be addressed by strong research and development programs. And here, governments can play a significant role. Some promising examples are radical improvements in conventional gasoline engines, lightweight materials for vehicles, advanced biofuels from cellulosic materials, hydrogen fuel cell vehicles, plug-in hybrids, blended wing aircraft bodies and unducted turbofan engines, and advanced diesel engines for freight trucks. Mr. Chairman, this concludes my testimony, and I'll be delighted to answer any questions.
Thank you, Mr. Plotkin. You gave us a lot to think about there. And Dr. Pilkey.
Thank the chairman and the committee for the opportunity to offer testimony this morning. I just want to note before I get into my testimony that 16 years ago this week I walked into Rayburn 2320 as a graduate student intern under Congressman George Brown, and I have a great deal of appreciation for the work that everyone does here, particularly the staff, and how important they are. My testimony today is based entirely on the information provided in the summaries for policymakers of Working Groups 2 and 3 of the IPCC. I begin with 3 assertions. Number 1, current debate over climate change represents a great opportunity to discuss what kind of future will result from our current decisions. Number 2, Working Group 3 indicates that the benefits of mitigation outweigh its costs, and based on this conclusion, mitigation should be a policy priority. Number 3, Working Group 2 is concerned with one of the many pressing challenges to global well-being and emphasizes that greenhouse gas mitigation is only one of many avenues for confronting these challenges. The problem that I am addressing today is that we may successfully meet the challenge of greenhouse gas mitigation, but still fail in the broader effort to promote a sustainable future for our globalizing society. In my written testimony, I argue that effective progress on coping with climate impacts, such as sea level rise, tropical diseases, and disaster impacts, requires a broad focus on sustainable development, including future development in the United States and other developed countries. I want to emphasize that nothing in this testimony, or in any of my work on climate change over the past decade or more, should be interpreted as being opposed to or somehow contrary to the mitigation of greenhouse gases. The main point is that a focus on control of carbon dioxide cannot substitute for a broader discussion of policies that will enable the most desirable futures. And indeed, this is one of the main messages of the IPCC, which is discussed in its Working Group 2 report, but which seems to be overlooked in the broader debate on climate change. Today, I want to make sure that this message is clear. The IPCC bases its work on 4 families of scenarios for the future, which it creatively named A1, A2, B1, and B2. The scenarios provide a basis for projecting how greenhouse gas emissions might grow in the future as input to climate models, which use the projected future emissions as an input. The IPCC scenarios are thus alternative visions of how the future might evolve. The IPCC makes no claim about the relative probability of each scenario actually occurring. In reality, of course, how the future evolves is a result of decisions that we make. In other words, by making decisions, we make some futures more likely and some futures less likely. The scenarios are also important because they allow for an analysis of the importance of decisions that lead to one scenario being realized versus another. The collection of decisions that lead to the realization of a particular scenario is a development pathway. Another way to think about this concept is as a broad notion of what is traditionally called adaptation. Now, the essential message of my testimony can be seen in 2 figures, and if I could have the first figure put up. This figure shows the IPCC assumptions for global GDP growth. So you see with that gray bar there, the IPCC starts with $20 trillion in 1990. Now, the IPCC, one of its scenarios, its lowest scenario, after you factor in the costs of damage from climate change, has the green bar showing future global GDP. So it anticipates that even with damage related to climate change, we'll be much wealthier. Under the IPCC assumptions, if we aggressively mitigate, we will be richer. That's represented by the red marginal addition. Now, if we look at another of the IPCC scenarios, the one with the highest global GDP, that's this green bar on the far right. And indeed, under this scenario, there's also benefits to aggressive mitigation. What I would like to emphasize is the difference between these 2 development pathways, these 2 scenarios, which is shown in this following graph. If you look at the subset, the little yellow box on the lower right there, the green bar represents the difference in global GDP based on pursuing one development pathway versus another. The red bar, the smaller red bar, represents the benefits of mitigation. And the point I want to make is that discussions of development pathways are far more important than discussions of mitigation. It's not a substitute for discussions of mitigation, but mitigation has to take place in this broader context. The conclusions to take from this analysis are as follows. Number 1, mitigation provides benefits under all scenarios I discuss in my testimony in almost all scenarios presented by the IPCC. Number two, in all scenarios discussed here, under the assumptions, conclusions, and metrics of value used by the IPCC, the importance of the development path far exceeds the importance of mitigation. Consequently, a focus on sustainable development should be central to any discussion of climate policies. Adaptation provides the link between sustainable development and climate change by ensuring that the capacity of societies to develop is not compromised by the impacts of climate on their socioeconomic prospects. Policy discussions about what sort of future we collectively wish to see unfold are myopic if focused only on greenhouse gas emissions. It would be the equivalent of a family discussion of their future focused only on their utility bill, ignoring their health care, education, housing, and everything else that matters. It is true, of course, that a family that does not focus on its utility bill may find themselves in deep trouble. So a focus on the utility bill is indeed important, but that cannot be the entire focus. With respect to the current political debate about the world's future focused on energy policies, the analysis presented in my testimony, based on the assumptions of the IPCC, indicates that our focus needs to be much broader, on the path of development itself. The most immediate way that the U.S. Congress can influence sustainable development as related to climate change would be to focus as intensively on the issue of adaptation as it has in recent months on mitigation. The Science Committee in particular can contribute to this agenda by ensuring that the nation's climate research portfolio is organized in such a way so as to reflect the information needs of decision makers facing choices about adaptation. For example, legislation proposed by Congressman Mark Udall and others on this committee is notable for its efforts to more closely connect climate research with the needs of decision makers. In closing, the IPCC has great potential to serve as a unique resource for decision makers. In my opinion, it will best reach that full potential not by replicating the important work of advocacy groups that seek to reduce the scope of choice available to decision makers. Instead, the IPCC should serve to empower decision makers by expanding their view and their options and to clearly distinguish the role of advisor from advocate and advisor from decision maker. Thank you very much.
Thank you, and welcome back, Dr. Pilkey. At this point, we're open our first round of questions, and the chair recognizes himself for 5 minutes. Mr. Plotkin, in your discussion of transportation, you had, I think, some positive views on biofuels. What are, in your opinion, are the type of breakthroughs that we need to make to really fully maximize those biofuels?
I think there are two issues we've got to focus on primarily. The first is that if we really are serious about getting significant amounts of biofuels into worldwide use and in use in the United States, we've got to move past corn-based ethanol and move to cellulosic-based fuels. And it may be ethanol, but it may also be a variety of other fuels for transportation. And in order to do that, we've got to bring the costs way down, because right now they're unaffordable. So that's number one. We have to continue and maybe intensify our research and development. And second, we really have to focus on what the effects will be of transforming very large quantities of our land and land elsewhere in the world into what is basically going to be a monocrop, let's say switch. Crops like these are nice from the standpoint of not needing a lot of pesticides and fertilizer, at least not to the same extent as row crops do. But on the other hand, they are vulnerable as monocrops to new kinds of pests and problems like that. We really don't know at this point what will happen if we transform a large portion of our land crops, so we need to study.
And in your testimony, and I'll quote here, you say, some form of fuel economy or CO2 standard or agreement is now in place in Japan, the European Union, China, Australia, and elsewhere, and the state of California, and a group of other states are attempting to establish their own CO2 standards. What are they doing in China now?
The Chinese have weight-based standards that are somewhat similar to the standards that the Japanese have, which are also based on weight. That is, the larger the vehicle, the less fuel economy they must achieve, which is, pretty logical. It's obviously a lot harder to get high fuel economy with a big SUV than it is. The difference in those standards is that they apply to every segment of the market. That is, you can't switch credits from one part of the market to the other. So it's actually makes it a lot less flexible for their manufacturers to conform with that than in a situation where you can have some cars more efficient and some cars a little less, and as long as the total fleet meets the target.
And Dr. Pizer, you mentioned international engaging in international reassessment. There are some that are concerned that only the United States, that we can't afford to take on this whole burden, and that we would be foolish, I guess you might say, economically, to try to do that unless you get China and other countries to participate. Don't necessarily advocate that, but that's what some would suggest. What is your suggestion on how we can engage other nations?
Well, I think the first step is to have a reasonable domestic policy. I think it's a lot easier to convince people to come along with something once you've already demonstrated leadership. We already have the European Union has in place an emissions trading program to deal with their emissions, and my guess is if we took action, most of the other developed countries would take action. Engaging poorer countries like China and India that are growing and have a lot of development needs, I think is going to be harder. I think there are a variety of ways we could do that, and just to mention 4 ways right off the bat. One is through expanded use of project-based crediting, which is currently the way the Kyoto Protocol works. 2 would be to try to get them to recognize policy reforms along the lines of the energy efficiency improvements that Mr. Plotkin mentioned that would be in their own interest and reduce emissions. 3rd would be to try to twist their arm and get them to take on caps through other things they care about internationally or just their own concern about the problem. And then 4th would be to try to engage their private sector on deals that would benefit particular entities, like trying to get the national gas company in China to become interested in getting a pipeline to China that would eventually reduce their emissions. So I think there are a variety of different ways that we can go about it, but probably the first step is a more serious U.S. policy.
And you'd mentioned in your statement, without prodding, ARPA-E and the benefits. What do you see as the benefits of ARPA-E?
Well, I think one of the problems on the technology front has just been the absence of a sustained commitment to develop major new technologies in the energy arena. I mean, if you look at the pattern of public investment in energy R&D over the past 30 years, it's been very unstable and it's been declining. And a lot of that hasn't been very flexible in terms of how it's been applied. So I think having a very serious and sustained management and support for energy research would go a long way towards dealing with one of the real pillars of the future of this problem.
Thank you and all the other witnesses. Mr. Hall, I now recognize you for 5 minutes.
Thank you, Mr. Chairman. Pizer, I heard your presentation as an argument for increased gasoline tax. Is that correct? Did I understand you correctly?
I think you have to recognize that if you're going to put into place a flexible policy to try to reduce emissions, one of the ways that works is by raising prices to try to encourage conservation. Now, if you actually look at what we're talking about in 2030 relative to where we are now, it's actually, depending on what happens over the next 30 years, it might be an increase or a decrease relative to current levels, but it would certainly be an increase relative to what they would be otherwise.
And you recommend that?
I think if we're serious about reducing use of fossil fuels and we want to do it flexibly, yeah, you have to raise the price of fossil fuels.
Is that what you mean by saying engage other nations and show some leadership?
I think there's a number of pieces to it, but one would be a serious market-based policy. The other would be the support
and
for
technology. And the leadership you want us to show is by going ahead and expending the money. What presumptions did you use on China's position when you arrived at that conclusion?
I'm sorry, presumption about?
About China, about their participation, about their emissions. You surely entered into some presumptions on your own when you arrived at the figures that you've given us and you chose the level of the year that you chose.
Well, I was basing the numbers that I was using on the numbers that were actually analyzed in the IPCC report. Now, if you're asking kind of my personal opinion about this, I think that...
I'll take that.
Okay. I think a policy where the U.S. starts with something modest, and we could discuss what modest means, and we expect China to follow us, at some interval, maybe 5 years or 10 years, and if they don't, we either go back on what we're doing or we, enact some sort of legislation to protect our domestic industries. That would probably make sense. But I think we do have to, I think if we're going to expect China to go forward, given their standard of living is a fraction of what ours is right now, we have to exercise some sort of leadership.
You mean go forward by taking American jobs?
I don't necessarily think that the policies that are being talked about would cost jobs. I mean, there would be switching
You
jobs.
use that in your presumption and arriving at the conclusions you've given us here today?
Presumption that it would cost jobs?
Absolutely.
No, I don't think it would cost
You don't
jobs.
think so?
No. It would be switching
Well, let's
jobs.
see here. Let
Yep,
me see
go ahead.
how reasonable you are. You looked at the three concentrations of greenhouse gases and then estimated that both the year 2030 and the year 2050 as to what it would cost to achieve these concentrations. And you used the lowest concentration, didn't you, in giving us your figure of 3%?
The 3% is associated with the most stringent stabilization goals.
Based
Yes.
on year 2030.
In 2030, that's correct.
Yeah. And but on the year 2050, what would your estimate be on the percent?
I could look at the numbers, but I'm going to guess it's probably about around 3% as well. It's a pretty constant number.
No change
It might be a little bit higher, but I don't think it's substantially. It's 5%? Okay.
well, I
can
used the
pull
middle.
it out.
I used the middle concentration of 2050, and these studies say that'd be 4%, as I stated. Do you disagree with that?
I would not
You stay with 3, no matter if it's 2020 or 2050 or 2090.
One of the things, the first point I really emphasized was the uncertainty we have predicting the cost. I would certainly agree that the cost could be as high as 4% in 2050. That is correct.
Okay. Well, I appreciate that. Mr. Pelkey, what do you think of the IPCC process?
Overall, I think the IPCC process is a sincere effort to collect and bring the best knowledge available from the science community, the impacts community, and economics community to decision makers. I do think that the IPCC process suffers from a lack of connection with the stated needs from decision makers. It would be nice to have the process start with decision makers saying, here's what information we need. Here are the questions we have. And that would shape the production of the reports. The first IPCC assessment in 1990 had its working group 3 focused on policy options. That changed over time. Now it's focused on mitigation. And I think something was lost in that process where we don't talk about a wide range of options now.
What changes would you recommend for the future reports?
I would suggest that I've often called for a quote-unquote working group 4, where we take the science, the impacts, the economics, and we integrate it. And we provide you folks, policymakers, with a smorgasbord of options, all the way from doing nothing to aggressive mitigation, adaptation, different forms, with the idea that their job is to provide you with what you can do, and your job is to decide what we should do.
I'll ask the panel, did you all use any presumptions that China was going to change their course and you arrived at the 3%?
That one of the things I mentioned was that all the studies, at least in the section I worked on, generally presume that the whole world, at some point in the future when the studies are done, are all working together. The cost studies are based on the idea of global participation, yes.
That'd be wonderful, wouldn't it?
Well,
Yes, sir.
Outside IPCC, I study China energy, and China is embarked on a path of reducing their energy intensity by 20% over the next 5 years. Now, they're not doing that for CO2 mitigation. They're doing that because they can't afford to be investing that much in energy. and they're very concerned about local environmental impacts.
Isn't it impossible to get to the 3% you all talked about if China alone stays on their present course?
Well,
Their
they're trying.
present course, and that's what we have to judge them on. They've given us no indication they're going to change or help us pay to cleanse the world.
No, they've changed courses. Their energy GDP ratio in this past year has declined considerably. I do give you a lot of credence to being concerned about how well they do, but they're trying very hard to change course.
I sure hope so. I'm out of time. Thank you.
Dr. McNerney is recognized for 5 minutes.
Thank you, Mr. Chairman. I want to thank the panel for coming out here and sharing your expertise with us. I'm going to direct my first comment to something that Dr. Pizer said. The cost of mitigation to keep temperature rise at 2 degrees centigrade or less, which is already a very large increase and has a very large associated global economic cost, has a very wide possible range of outcome from +4 to -6%, which means that if we mitigate, we'll create new sectors of the economy, some of which will focus on our rural communities, creating a new prosperity in our rural areas which are now having difficulties. And if the cost of inaction or inadequate action will very likely be very, very much higher than that. So just in terms of probabilities, it's a good outcome to go ahead and make the investment in mitigation. Now, Mr. Plotkin's comments on the transportation reinforce that assessment that mitigation will improve the economy. So my colleagues on the other side of the table often focus on the taxes, and particularly on gas tax. But the panel's testimony indicates to me that policies can move forward without relying very much on gas tax. Can you comment on that, Dr. Pelkey? Yeah. Well, can you comment on my assessment that investing in mitigation will actually improve the economy, especially the rural economy?
Yeah, I guess my view on that is that at some point we should stop debating what the economy and the climate system is going to be in 2030 or 2050 and start doing things. And by doing things, I suggest that we start taking actions. States are taking actions, cities are taking actions on greenhouse gases, and we should evaluate them. And those things that have net benefits, we should do a lot more of those things. And those things that don't work and have costs, we should do less. And I think the notion of improving the economies in rural locations or fostering technological innovation that stimulates the economy are all plausible, and they're all supported, I think, in the economics literature. But we won't know in the real world until we actually start doing things.
Okay, I'm going to switch a little bit to Mr. Levine. Building efficiency seems to be a very critical part of eliminating CO or reducing our CO2, but I don't know exactly what would be effective in terms of building, mitigating, or how do we get our people that own houses to invest in the things they need to, and how do we change buildings? Is there new technology on the horizon that'll make this more transparent? This approach more transparent?
Well, the first thing you want to do is put policies in place, and California is probably the best example. California has been able to keep energy use per capita in buildings constant since 1972, whereas the rest of the country has increased by, I think, around 70%. They've done it through aggressive appliance efficiency standards, which has the advantage of educating consumers. They only get to buy cost-effective, efficient appliances. They've had very aggressive, I should say I'm from California, so are you. We've had very aggressive utility demand-side management programs, which means the utilities go in and offer rebates and offer fixes within houses to improve efficiency within the house. That's been very effective because it goes into areas where consumers really just need help. and then we've had a successful set of building codes. So without any new technology, and there are, of course, new technologies, we've been able to keep energy use per capita constant in the state for, how many years is that? 40 years. Now, there are new technologies, and some of them have come in almost automatically. There was a big push not too many years ago to get builders to build their houses tighter when it was discovered that leaking houses caused large losses in energy use. And that's been very successful. It's been successful through training programs among builders, word of mouth. We now have this sort of unfortunate situation, or I guess you could say the glass is half full, fortunate situation where we have compact fluorescents, and it turns out that while they save 3/4 of the energy and they perform very well, very few of the sockets in our houses in California have them. Well, we need to do something about that. It's a trivial matter. The utilities did a sensational job in California and elsewhere in getting more efficient fluorescent lamps in. So those are the kinds of things you can do in the near term. In the longer term, it's a bit of a tougher problem for commercial buildings because you really want to have much more advanced technology to have integrated systems that control and give you feedback on the buildings, and for that R&D is needed, demonstration programs are needed, but we could get to close to zero energy buildings over time.
Thank you, Dr. Levine. Mr. Sensenbrenner.
Thank you very much. I've heard an awful lot of testimony this morning about raising the price of energy. I've heard the word tax. I've heard the word substantial tax. I've heard the word increasing the cost, whether it doesn't involve a tax to raise the price of energy. And I've heard questions from at least two of my colleagues relative to what happens if we do that and China does nothing. Now, just by way of a historical note, since I'm the graybeard around here, is in 1993, my Democratic colleagues voted for Al Gore's carbon tax, and then they voted for a big package that included an increase in the gasoline tax, and in the next election we won 52 seats and took over control of the House of Representatives. So I hope that the tax word is falling on very productive ears on the other side of the dais. That being said, I went to Kyoto as chair of the delegation in 1997, and the entire delegation met with the Chinese, and they said no way, no how are they going to reduce any carbon emissions, and they've maintained that position up to and including their submission to the meeting of IPCC Group 3 in Bangkok. All of us are getting hit by our constituents relative to the outsourcing of jobs to countries like China and India. And how do you expect our manufacturing sector in particular to compete if there is a huge increase in the energy that they need to make their products here, but no increase in energy costs in China and India? These are decisions that we as policymakers are going to have to consider if we were to accept any of these recommendations. Anybody want to take a whack at that? Dr. Levine?
I think we have a bigger issue with exchange rate with China. And if we could get the exchange rate in an appropriate parity, I think many of these other issues would be second order. We have much higher energy prices in Japan, in Europe, and
well, if I can reclaim my time, the Japanese economy has been in a recession for the better part of the last 15 years and only has recently turned around. Most European countries have got double-digit employment. I don't think any of us, whether we're Democrats or Republicans, want to consign our economy to that kind of a fate. The real issue is, how do you deal with this without China and India being on board? And what's the IPCC doing to be able to come up with a matrix that would encourage the Chinese and the Indians to be on board, because they would view it as in their economic best interest? I haven't heard anything lately on that.
I think IPCC doesn't do anything. They're very advisory, and this is within the realm of
But IPCC is giving advice to policymakers. We're policymakers. We're policymakers where our existence here is dependent upon our voters sending us here. And listening to the prescriptions that you and the panels at the previous hearings have had, I'm supposed to be the happy bearer of good news, saying we're going to increase your taxes, we're going to double your electric bill, we're going to double your natural gas bill, and we're not going to make China do anything, so when everybody gets thrown out of work, then I guess we'll increase the deficit to provide some kind of an adjustment program for you. That's not a winning political matrix for anybody, is it?
If I can just respond to the first point that you were talking about, it definitely does not work for the U.S. to pursue a policy that's adverse for its economy if China, it's adverse for its economy, period, but it's also not sensible for the U.S. to do something that raises its energy prices if China and India don't do anything and all of our industry just goes over there and emits over there. It doesn't help the economy, and it doesn't help the environment. So the question is, what do we do in order to bring China and India along? And I guess my argument is that we have to do a lot of different things, and one of them is probably take a modest first step. I don't think we do something that has dramatic impacts, but we do have to take something that says that we're serious and convince them to come along with us.
Thank you. My time's up.
Mr. Carnahan is recognized.
Thank you, Mr. Chairman, and thank this panel. It's been very insightful and inspiring to hear some of the possibilities that are there, and pulling this information together can help us with our public policy. And I'll tell a little bit about our experience in St. Louis. We had a prominent building company there, a prominent construction company, that renovated an older structure. It's gotten the Platinum LEED certification, the top, I guess, green building certification you can get internationally. Was so successful in doing that with their own building, and the business executives there talk about the economic benefit to their company, the long-term savings they're going to have with those things they've designed into the building. They actually created a green building design subdivision of the company, and they're going out and selling this. And we've had a lot of international visitors come to St. Louis to see this, to see how it can be done. And so, this is a winning business model, a winning economic model that people are using, and we've seen that locally at home. And I wanted to ask Dr. Levine about the testimony about by 2030 about 30% of the emissions could be saved. And really, if you could just list off, what are some of the technologies or practices that help us get to that point that we need to be focusing on?
One of the biggest growth areas in both residential and commercial buildings is plug loads, things you simply plug into wall outlets, and when they're not on, they're hot, and that is when they're not producing anything useful, they're producing heat. What we need to do is to develop a chip so that when they're plugged into the wall, they're effectively not doing anything, and you're saving electricity.
But that would be something built into the plug itself, or into the appliance?
Into the gizmo that you plug into the wall.
The plug itself.
The plug itself.
Okay.
Yeah. And right now the estimate is that you have the equivalent of a refrigerator worth of 1 to 3 refrigerators worth of those things in your house. So there are very large savings that you just aren't aware of.
Has that chip been developed? Is that?
It is under development and not yet available in all applications. You know, you have set-top boxes on your TVs that are using 20 plus watts, and they could be using 2 to 3 watts. And we need to get industry agreement to cut them down to 2 to 3 watts, and that's a process that's going on right now.
Where is that being done?
Well, EPA has an Energy Star program. We're involved in it and trying to cajole the manufacturers. The California Energy Commission is trying to make a pest of itself and getting appropriate attention. Windows can be better. We're working on the next generation of windows that are dynamic windows that respond to different temperatures outside. I think for residential buildings, insulation is in pretty good shape. There's still ways of reducing air infiltration, particularly in the duct work in residential buildings, and there are now technologies to do that. And I don't want to go at length on this, but I do want to say that I want to say 2 more things. Commercial buildings are actually a very unfortunate situation, large commercial buildings. They've had very, very little attention on R&D, and the opportunities are very great. They're systems, and so it's very hard to do R&D in a system instead of a widget. And so we need to treat them as systems, and we need to work on them as systems, and we need to do demonstrations with control systems and the building interacting. And then, of course, for the longer term, you want to have building integrated photovoltaic systems in buildings. That's not available now, but it will be in due course, one hopes.
Thank you, Dr. Levin.
Thank you.
Just for the information of the Science Committee members, former Chairman Bowler a few years ago asked the Carnegie Mellon University to do a research project on the Science Committee and energy efficiency. We have picked that up, and talking with the speaker this fall, the Science Committee, all of our rooms will be made a model for the Capitol in terms of energy efficiency. Later, you're going to see, I've got quite a bit of legislation which is concerning energy efficiency within commercial and residential buildings, most of which will come through this committee, almost all of which is off-the-shelf technology now that is not, you know, anything that is way outside. The commercial residential section is the largest user of energy, and I think there's a lot of things we can do. One thing I think is of interest, and I think certainly the federal government should take the lead, but what will happen oftentimes is an agency will say, well, you know, we don't have enough money as it is, so we can't not waste money, but we can't use money on insulation or more expensive light bulbs because our budget's too tight. So we want to create a revolving fund so that agencies can come to this revolving fund and with a plan of X amount of, again, off-the-shelf types of insulation or changes that will cost $1. And some expert will say that the savings you can repay that with your energy savings over 3 years or 4 years, and so they will pay that back in. So we're going to do, I think, some creative things, again, off the shelf things that should hopefully continue our unanimous. Yes, Mr. Bilberg.
You know, Mr. Chairman, I come from a state to where we only use 2 forms of energy for air pollution point of view. And we talk about putting in the light bulbs and everything else. But as long as the United States government in Washington is generating its electricity out of the dirtiest technology and the highest emitter, coal, I really find it interesting that we're talking about 5% reduction doing this and this, when the elephant in the room is not being addressed. And that is, the fact is that we have, over the last, since '92, the federal government has tried to decommission zero-emission generators across hydroelectric, whatever. But as long as we're looking down the pipe of coal-burning congressional facility over here, I really have a problem with us having a moral high ground, setting an example for the rest of America, let alone my constituency out there, with the fact that what Congress does to generate the electricity for this facility, you'd go to prison in California for it. So I just want to say, as we talk about all these neat things, I'm still in culture shock when I come back here and see those coal trains coming in. And I know it's an inappropriate thing. It's not politically correct to say right now, but I just say again, we've got to confront this issue, and we've got to address the source of the emissions, which is the power plants. And I yield back. Thank you, Mr.
Thank you. We want to see you come out of shock. And that's the reason that the Speaker has already introduced a green capital initiative. That's the reason that we got approval to do the science room. Certainly the coal-fired plant is of real interest. I will point out that most of the what looks like the gray stuff that's coming up is steam. But you're right, and there needs to be a change, and I think, and the federal government needs to take the lead, and you're going to see that start to occur. And Professor Rohrabacher is next.
Thank you, Mr. Chairman. I certainly appreciate my colleague from California who, along with this member of Congress, enjoys transportation vehicles that have totally renewable, based on renewable energy in terms of tidal and wave-related. We both, of course, live on the ocean. Yeah, that's what I'm talking about is our surfboards. Let me just note, and then we'll go into a more detailed discussion about right now. What we are talking about is based on the idea that man-made global warming is a reality, and of course that I totally reject. And I might add, I've put on the record numerous scientists from MIT and other major universities throughout the world who disagree with that and think that it's basically being used as a football to push other agendas. If that's the analogy, I guess, having a football to push agendas, but as a method of pushing other agendas. I would like to put a quote on the record here by Timothy Ball, who is, of course, a professor of climatology at University of Winnipeg. I believe it or not, global warming is not due to human contribution of carbon dioxide. This, in fact, is the greatest deception in the history of science. We are wasting time, energy, and trillions of dollars while creating unnecessary fear and consternation over an issue with no scientific justification. Let me add that Dr. Ball's observation is not different than I say than numerous other scientists who now have been just totally ignored in the public debate in order to move forward with these very revolutionary concepts of what we should be doing to curtail or change the economic way we and technological way that we manage our society. Back to today's hearing about what we're really talking about is IPCC and what was recommended there. I have a quote here from Dr. Christopher Lancia, who was taught by NOAA and also has a doctoral degree from Atmospheric Sciences.
he was part of the IPCC effort, and he said, "I am withdrawing," meaning from the IPCC, "because I have come to view the part of the IPCC to which my expertise is relevant as having become politicized. In addition, when I have raised my concerns to the IPCC leadership, the response was simply to dismiss my concerns," which I have seen so often, where people just want to say, "The debate's over," and not handling the actual specific arguments that are being presented by those who question this. And then I go on with Dr. Lancia. "I personally cannot in good faith continue to contribute to a process that I view as being both motivated by preconceived agendas and being scientifically unsound." Now, first of all, I'd like to ask the witnesses that were part of the IPCC process, is Dr. Lancia just some guy who is dishonest about this, or is he someone who has raised some serious concerns about the IPCC process?
Mr. Robacher, we have two votes coming up. What I would suggest is the witnesses to answer your question. We'll then go to Mr. Lamson and see if we can get that one in, and then witnesses, if you will excuse us for about 30 minutes, we have to go vote, and we'll be back.
Mr. Chairman, does that mean that possibly I could have the rest of my 5 minutes when we come back?
You want to start all over, or you could let them have, you had a minute, 30 seconds left if you'd like to go ahead and complete.
Thank you. Go right ahead and answer, and then I've got one other thing to put in the record.
Well, first of all, I mean, we were working on a different part of the assessment. I guess your gentleman was working on the science part. The first part, we're working on mitigation. There are a lot of people involved. It can occasionally got sort of chaotic. I did not feel that it was a political process at all. And it is also a process that is, I come from an agency, the Office of Technology Assessment, which had a really extensive review process. This was far more extensive than that, and that in my career, that was the most intensive. So I think that a lot of that is filtered out if it gets into the system anyway.
Well, we have one scientist who was part of it who felt that it was totally
part of a
compromised.
different part. I have no idea what went on, and I don't think any of us do.
Let me just, for the record, I'm going to put this article into the record from Newsweek magazine by Richard Levine, who's a MIT professor, very respected man, who says the current alarm rests on the false assumptions that not only that we live in a perfect world temperatures, but also that our warming forecasts for the year 2040 are somehow more reliable than the weatherman's forecast for next week. And let me know, even today, from what your testimony is, I heard the words best guesses, I think was the word that I jotted down, and in terms of what these models that we're talking about. We should not be doing something that will affect the standard of living of people who, in our country, middle Americans who earn $50,000 a year, affect them dramatically, which is what I have heard, based on these type of charts which are being called into question, these types of projections, they're being called into question by some of the top scientific minds on the planet who are being ignored in this debate.
Thank you, Mr. Robacher. And Chairman Lamson, if you would conclude this session.
Thank you, Mr. Chairman. I may give you back a little bit of time. I'll try. I would like for Dr. Levine to talk for just a minute about maybe more. You've perhaps already done some of this, but obstacles that keep commercially viable technologies from wider spread use in the country. I think that your summary for policymakers includes a table with a number of building relevant mitigation strategies that are available. What are some of the obstacles? Why aren't more people more anxious to do those kinds of things?
I think one of the biggest problems is transaction costs. How much time do you have to shop? How much time do you have to shop to get the most efficient product? And how do you know that it really is the most efficient product? And so people really have limited time. Another aspect of that is availability of technology. Turns out, interestingly, that appliance manufacturers were not making the most efficient appliances that would sell on the market because they had a marketing strategy that gave them a better return by not doing so. And so until appliance standards came in, they had no incentive to put more efficient technology onto the market. You've got extremely complex design processes for commercial buildings where you have engineers doing one thing and architects doing another thing. They don't talk to each other, and everybody gets paid based on how much time it takes to do the design, and nobody gets paid on how much energy savings you get in the design. So the design process itself is flawed. It's often difficult to get extra financing for more efficient products.
Can we trust the efficiency guides that are placed on appliances today?
I think we do now, yeah. The EPA has done a terrific job in its Energy Star program, so that problem has in good measure been overcome. And also Appliance Standards, I think, has done a very good job.
Good.
But, you know, it's a matter of trust. You're dealing with these gizmos. You don't know what they are, and whom do you trust? You have salespeople at one end and the other end. It's a tough job.
Indeed. Let me just ask Dr. Plotkin, if I may. You'd made a comment about if U.S. new car and light truck fleet's fuel economy would have been 24% higher had we not changed the weight of vehicles. Would you comment on that, and also on weight or body shape changes as far as automobiles are concerned?
Well, I think in vehicles, there's something a little different happening than in buildings. I don't think there's a lot of trade-off in buildings with energy savings. You've got a more efficient air conditioner. You're going to use it to save energy, unless you decide to chill your house a little bit more. But in vehicles, making a vehicle more efficient, or a technology that can make a vehicle more efficient, can be used either for fuel economy, or it can be used to improve performance or make the vehicle bigger. That's sort of similar to a house. You can make the house bigger, obviously, if you can reduce the energy savings.
Would gentlemen yield back? I'm sorry, we're getting close on time.
Yes.
Let me make this suggestion. It's my understanding that we have a motion to adjourn, which will be followed by 10 minutes of debate on the National Defense Authorization Bill. And you know how the long 10 minutes can go. And then we'll have 2 votes. So what I would suggest, I don't mean to be overly inconvenient to folks, but I would suggest let's go vote and then come back here between the debate. You know, starting with, we can get several questions in it. And Mr. Plotkin, I understand you have to catch or not, Mr. Plotkin.
Yeah.
Okay. You have to catch a plane, and your presence has been appreciated, and you are excused. And we will, if there's no objection,
no objection.
We're going to come back after this vote, and we'll try to, if we can finish, we will. The committee is back in session, and Dr. Ehlers is recognized.
Thank you, Mr. Chair. My first question is for Dr. Pielke. First of all, I appreciated your suggestion that the concentration of IPCC should be on recommendations for policymakers. I appreciate the work they do, but it'd be helpful to have it translated to meet our needs. On your charts, perhaps I didn't quite understand, but you showed very small mitigation costs compared to economic growth, as I recall. Did I understand that correctly?
That's correct.
Okay. Now, what were you implying that we could forget about mitigation because the costs are so small compared to our economic growth, or are you trying to say we should mitigate because the cost is so really so small compared to economic growth?
Yeah, well, I guess I would say small is a relative term because we're talking about trillions of dollars. And so
Right.
if you can benefit the global economy by a few $1 trillion, then we should do that. So the message from that is that mitigation provides a net benefit. But the broader, bigger picture is that that's not the only set of decisions we have to make about our long-term economic future. And the difference between the low GDP future envisioned by the IPCC and the high GDP future is something like $80 trillion, which is about 80 times larger than that mitigation benefit. And I guess my overarching point is that we should be paying as much attention to achieving that $80 trillion as we are to achieving that 1 or 2 trillion by 2050.
Okay. Now, how do you see this relating to less developed countries or even countries which are rapidly developing, such as China and India?
Yeah.
How do you see their decision makers reacting to this?
Yeah, I see this as the key question, and I appreciate you asked it because in the discussion earlier about China, I think this point was missed. China is not something to fear. The rapid development in China is an opportunity.
Yeah.
China is using enormous amounts of expensive energy. If the United States, through an innovation agenda, investing in the development of cleaner, cheaper energy technologies, gets there first, then the Chinese are going to rush to be buying our products. So it seems to me that if we think about not just climate change, but innovation, competitiveness, a much bigger picture, the development in China is not something to be afraid of or that should limit our action, but it's really an opportunity, and particularly for the science community, to invest money in innovation that puts us out in front so that our economy grows and we capture some of that $80 trillion in growth.
Well, I totally agree with you on that. I'm dismayed that some of my colleagues here in the Congress seem intent on making China into an enemy, whereas I like to see them as a potential customer, not just as a supplier, but a customer of us. Good example might be in terms of what IPCC worries about would be nuclear development. In our country, we have not done a good job of developing nuclear plants, but if we made an effort at it, we have a very large market in China. Right now, I'm afraid that market's going to go to France or some other countries simply because we're not latching onto it. So I appreciate your comment on that. Also a general comment for both of you, if you wish to comment. Mr. Chairman, you made some comment about you mustn't look at energy savings just in terms of cost, must look at the other benefits as well, the other issues involved. I certainly agree with that. And I have been gung-ho about energy efficiency for years. In fact, back in the mid-'70s, I got fed up with the insulation in my house. It was done according to standard practices, but I did it myself, redid it myself, plugged all the air holes where the cold air, in Michigan you get a lot of air, cold air would filter down from the attic into the walls from every opening that you made for electric cords and everything. I sealed everything off, sprayed the insulation back in, saved 1/3 off my utility bill. Now that's a very substantial saving. However, if I had hired someone to do it, it would not have been much of a saving. The fact that I did it myself, I earned a lot of money very easily. I don't know how we address that. If either of you have any ideas of how we can change either the system or change the mentality so people are more prepared to spend money on energy conservation. And I'm not talking just about individuals. I find the business sector that way too. I have never understood why in the business community they are totally gung-ho about efficiency of operation, efficiency of this, efficiency of distribution, all that. But you talk energy efficiency to them, this is a silly, fuzzy-headed, knee-jerk liberal idea. And it's still money. And when EPA did the Green Lights program, it was a real eye-opener to industry that they could save that much money just by replacing the lighting. So I don't know if either of you have any comments on that.
Well, I mean, I think one possibility is improved information programs, probably through the utility companies, to make people both more aware of these opportunities that exist, as well as provide them with loans potentially to try to, if they don't want to actually install the installation themselves, to hire somebody to do it. I think that's a big piece of it. Another possibility is to think about tighter building codes. That's usually something that's done more at the state and local level, but requiring builders to actually use more insulation when they're building houses would go a long way towards dealing with that problem too. I don't know.
Well, actually, that's the most cost-effective way to do it, through a building code, because redoing a house later is far more expensive than doing it right the first time.
But time has expired. Just
one last comment on the utilities. The difficulty with the utilities is they make more money by selling more energy. So you have to totally restructure the reimbursement mechanism for utilities. Yield back.
Thank you, sir. Mr. Smith is recognized.
Thank you. I regret that our witnesses are disappearing, but I'll try to make it quick, and perhaps anyone on the panel can respond. But earlier statements suggesting that we need to get away from corn ethanol and transfer to switchgrass. If either of you can speak to the energy contents or renewable energy contents of a bushel of switchgrass compared to a bushel of corn, if you could speak to that. Also, a statement was made by the gentleman who had to catch an airplane about monocropping relating to renewable energy. If you could comment on that. And then also, we heard earlier, even from my colleagues, about coal and about China's approach. And if you have the data on China's coal energy production now, how many plants are due to come online, whether or not it's clean coal technology, and then also, I remember maybe it was Dr. Levine who said that China is already striving to be, I think, more energy efficient or something. Anyway, in my estimations, suggesting that market-based approaches are being engaged in China. I realize that is a lot of questions for a short period of time, but I do want to speak to the issue that market-based approaches are working a great deal. I find it hard to imagine that my good friend from Michigan accuses business of ignoring the cost savings of energy efficiency. And those are my words, so I don't want to change your words. But already the desire to engage in the capitalist economy many times works. I am afraid, and I've visited India, and the environment there is very, very concerning to me. And then I come home, and Mr. Sensenbrenner certainly spoke to the fact that we get beaten up politically over all these jobs going to Asia, and to think that they would be exempt when we would not be. So if the panel would care to respond, perhaps Dr. Pizer, if you would begin.
Well, I'm going to skip the switchgrass versus corn ethanol. That's not really something I could speak well to. Unfortunately, Mr. Plotkin had to leave. Let me talk a little bit about, I guess, coal, because that's something I know a little bit more about. There was a recent study done by MIT, the MIT coal study, which really looked at this problem in a lot of detail. And I think one of the conclusions of that study is that coal is an incredibly important part of our energy mix as well as of China's. And to answer your specific question, I think they're building something like the equivalent of one 500 megawatt plant every couple of weeks, basically to feed their rising demand for energy. And these are not the most efficient plants in the world that they're building. So the recommendation of this study, recognizing the importance of the climate change issue, was really to call for a large research effort on capture and storage technology for coal plants. Because if we're going to continue to use coal in this country and China's going to continue to use coal as well, that's going to be a really critical technology. And so at this point, it's something that there needs to be a regulatory framework, there needs to be large-scale demonstration projects, and that's kind of the key story for coal. Dr. Levine might be able to speak to the energy efficiency programs in China a little bit better than I could. I guess I would say just on the trade side that keeps coming up, before a modest program to get started, the consequences for trade are just, they're in the noise. I mean, there are a lot of things going on that are problems for American industry, and we need to really seriously work on those problems. But I do think it is possible to get started and eventually get China along with us without having an adverse impact on jobs in the United States. So.
Okay, if I might interject, also on the taxation suggestions, that taxing energy would lead to more conservation. Certainly that could be the case, but I would suggest, I can't remember, I apologize, which member of the panel suggested that recycling tax dollars would lead to great economic results. Would you suggest that the same dollar in taxes would leverage better results than a dollar, the same amount in the private sector with capitalist objectives?
I think that the point that was being referred to was a general theory of taxation. When you tax something, it generally discourages it because it costs more. And if we have a choice, usually we'd like to tax things that are bad, like pollution, as opposed to taxing things that are good, like labor and capital. And so the obvious point is that if we were to switch off of some of our taxes on labor and capital and put more of tax on pollution, like carbon dioxide emissions, we could actually increase the efficiency of the tax system, and that's a benefit to society.
Okay. Dr. Levine, while you were out of the room, I was inquiring about China. I think you made some statements about China's efforts already underway in terms of more efficiency, and I'm assuming that you meant more environmentally friendly. Now that it's my understanding, as Dr. Pizer pointed out as well, that new coal plants are coming online in China without clean coal technology that make our efforts seem pretty pristine. Could you speak to that?
Yeah. I would disagree a little bit with Dr. Pizer. Excuse me.
Go ahead and take that.
No, I'm not going to do that. Thank you. I'm not going there. Most of the coal plants coming into China are at least efficient, but they're not designed for carbon capture and storage. Neither are ours. And so we find ourselves in exactly the same situation. The problem in China is that they're building so many. They're building, they have this tremendous construction activity in coal-fired power plants in China. And this is frightening. Now, what's to be done about it besides turning my phone off? where I can actually make it really turn off. Well, the best thing to be done about it is to cut demand. And the Chinese have been slow to move in that direction. They had until 2000 been effective in cutting the growth in demand, and then it got away from them. They've embarked on a program to cut the growth in energy intensity by 30% in 5 years. This is a remarkable goal. It's not only a goal. They have organized their industry. They have given quotas to industries. They have given quotas to cities. They have put governors under pressure where if they don't do the right things, they stand to lose their jobs. They are attempting to create a bureaucracy that will once again provide incentives and no doubt punishments for accomplishing these objectives.
The gentleman's time has expired. Vice Chair Lipinski is recognized.
Thank you, Mr. Chairman. I'd like to thank all our witnesses for their testimony today. I think that what we really need to, of course, focus on first is the very low-hanging fruit. And last night I was in the Rayburn garage, and I saw them putting in CFLs, and was happy to see that as part of our Green the Capital initiative. I have an amendment today of the DOD authorization bill to require the DOD to use high-efficiency bulbs where practicable. I also have a bill to require GSA buildings to use high-efficiency bulbs, put in high-efficiency bulbs when they're replacing bulbs. It seems that high-efficiency lighting is certainly such an easy way to, save energy, and you also save money, which is not something that you always find when you're saving energy. That leads to my question here of all the recommendations that you've given. And I appreciate hearing all these and hearing your expert testimony on them. What I would like to ask is for prioritization of these, ways to go about, helping reduce greenhouse gases and saving energy. How would you prioritize them? Like I said, I would think you go after low-hanging fruit first, things which are less costly and save the most, and just balancing those things out. What do you think? And I'll start asking Dr. Levine. If just quickly, what would you prioritize that we here do first to work on this problem?
Well, highest priority is efficiency. You do well in buildings. You can do very well in industry, not so widely known. And you heard from Steve Plotkin that we have a long way that we can go in transportation at low cost or net benefit.
Now,
those are the first things you do.
In terms of efficiency, what types of requirements? Obviously, you could talk cafe standards with automobiles, or what ways do we get there to be more efficiency in various, in industry?
Well, those ultimately are political questions.
Well, that's why we're asking you for what the easiest way, have the most impact for the.
Look, for industry, my own personal preference would be to have industry agree to voluntary standards that they take seriously. I think they can do it. I think you've seen it done in other countries. But this is sector-wide. This is not, plant by plant. For cars, auto fuel economy standards, alternatives to gasoline. I've already talked about, I think, what the best policies are for buildings. Okay. I think when you get into the supply side, you are going to talk about some taxes and R&D, and you have to talk about R&D for efficiency as well, and you'd like to recycle whatever the taxes are into R&D.
Okay, Dr. Pizer, one or two things.
Yeah,
The first things.
one or two things. I think I'm a little bit more skeptical, maybe, with all due respect to Dr. Levine, about the voluntary programs. The work that I and some colleagues have done suggests that there are some opportunities to get reductions and improvements in energy efficiency from voluntary programs, but they're usually limited to maybe 5 to 10%. And if you really want serious activities in the long run, you're going to have something stronger. Although 5 or 10% wouldn't be a bad start, I guess. The other thing that I think is a really important priority is sending signals to businesses so that they invest in new technologies and R&D. And I think that there are a variety of different ways to try to send that signal to business, but one of them is to suggest that the future is going to be somewhat different. If we really care about greenhouse gas emissions and the future is going to be about reducing those emissions in more and more serious ways, we need to convince business of that, because if they keep making the same investments to improve conventional technologies, then we're never going to get the investment in the newer technologies that we need.
Thank you.
If the gentleman will yield back, then Ms. Biggers is recognized. And we'd like to, has the 15 minutes started? Okay. I would like for our three remaining members to have a chance, the best you can, here in these next 10 minutes to get your questions in.
I will be short. I know that Dr. Ehlers mentioned nuclear energy, and I think that is something that we really have to look at. And what happens all the time is we look at the short term and then don't move ahead with the nuclear, particularly when the gas prices go down, or we seem to be lulled back into not looking at reducing our dependence on foreign oil and gas. So I think that always has to be in the forefront. And we are talking about $2 billion probably to build another nuclear plant, but there are companies now who are already looking at getting the licensing and things. So I think that they are moving ahead. A few years back, then Secretary of Energy Spence Abraham came to my district and to Argonne to look at the fuel cell for the hydrogen cars, and it was a big fuel cell. And he said, "How long is this going to take before we will see it in cars?" And I've already driven a hydrogen car around the streets of Washington, which is kind of scary because it's $1 million car right now, and I don't drive around the streets of Washington that often. But I think as we move ahead, I was a little disappointed to hear that we haven't done anything, because I think EPAC, the 2005 energy bill, really had a lot in it. Unfortunately, everybody focused on the fact that we were for oil and gas, the tax credits, but there are a lot of tax credits. For example, we have a bill in the energy for buildings for contractors, for architects who develop an energy efficient building. And I think we're moving ahead so much, and I don't know whether we need to combine that all into this one big project. But the president has the advanced energy proposal and GNAP for nuclear, and so I think what you're doing is great. But I think we need to say that we are doing these things and to find the ways to increase the need for and increase the visibility of our plans, because it's crucial. But so I'm not going to ask a question. I'm just going to make a yield back.
Thank you, Ms. Biggers. And Mr. Bilbrey is next.
Yes, Mr. Chairman. Gentlemen, I knew about the retrofitting or whatever, and I'm just trying to picture my years in air resources in California. California reduced its emissions by 50%. The air is twice as clean now as it was 20 years ago with twice as much population. There's no way we would have done that talking about retrofit. Stationary sources is where we've made the major reduction. When it comes down to zero generators, have you guys specifically addressed the transformation from fossil fuels to nukes, either fission or fusion?
Yes, I think most of the studies of stabilization have a hard time doing it without some increased role of nuclear power. Certainly the higher end estimates are, that's what a lot of times drives it, is constraints on nuclear power. There are obviously a lot of problems with nuclear power, as the previous person mentioned, but those are probably going to have to be dealt with if we're really serious. The other big...
Well, before you go
Sorry.
the problems, what's the cost comparison between nuclear and another alternative zero-generation facilities?
For base load, and I invite my colleagues here to correct me, but for base load, I don't think there really is an alternative right now for zero emissions. I mean, unless you're talking about expanded hydropower, things like wind and photovoltaics and centralized solar power, are not going to be cheaper, and wind isn't really base load. So, I think that really is the alternative. Over the longer run, I think people are very excited, are hoped for coal with capture and storage.
And what?
Coal with capture and storage.
Well, that's an interesting thing. Is because I'll tell you something, we talk about capture and storage. It's tough enough to find a disposal site within one state. When we talk about putting it 2 miles down with 3-state jurisdiction, and then people will raise later, what about this, the questions. I just think capture and storage is sort of being acted as if it's not an issue. It is a huge issue, and regulatory it's a huge issue. Mr. Chairman, I know my time's, we're on short time.
Yeah, why don't you ask one more question, and then we'll give the rest of your time to Mr. Gingrey, if that's okay.
Question is this. There are 3 major opportunities here. One's nuclear, one's hydroelectric, and the other is biofuel. But biofuel needs genetically engineered organisms to make it practical. Wouldn't you agree with that?
It's not really my expertise. I might ask some of the other people to comment.
I tend to agree with that.
Yes. So, Mr. Chairman, my point being is that the 3 major options for generate are those that have been actively opposed by people who claim they're supporting the environment. But we have to break those taboos, stop away from the sacred ground, and move into practical applications. That the 3 technologies we got to think about when we talk about destroying hydroelectric dams. What is the big picture here, not just what's the micro picture. We've got to talk about next generation nuclear, and we've got to talk about genetically altered enzymes to be able to produce the biofuels that everybody touts. But when we get to genetically altered, you watch the people will come out of the woodwork to oppose it, and we got to find reasons to find answers rather than always excuses to oppose it. Thank you very much.
Thank you, Mr. Bilbrey. And the last word to Mr. Gingrey.
Definitely not the last word, but I thank you, Mr. Chairman. Would all 3 of you briefly comment on the thought of maybe having a working group 4 of the IPCC that was made up of maybe not pure scientists? You made your case, I think, pretty well, although my friend on the upper row, Mr. Robacher, would not agree with me on that. But it seems to me that a lot of the discussion that goes on is, well, what do we do about it? And what's the most cost-effective way 20 years from now? How much will we be dependent on coal? Dr. Bartlett talks about that a lot. And, will there be cap and sequestration technology? Hopefully there will be. But it just seems to me that a working group 4, if you want to call it that, under the IPCC, to say, okay, now we've got the scientific facts that we've accepted. What is the best, most economical way? What's best for our economy? What's best for our health? What do you think about that?
I think that doing it via the IPCC might be difficult because it's an international organization and all the international politics involved. But in the United States, this could be done right away. And in 1992, the National Academy of Sciences published a massive report called Policy Options on Climate Change, a big green volume. And in it, they surveyed a whole wide range of options, mainly energy policy, some adaptation. But this committee could very easily motivate such an entity to update this report. What are our options for mitigation, for adaptation, both narrow, focused on the climate issue, but focused broadly on what actions can we take that has a side benefit of reducing emissions? And you could have a report next year. And I think the sooner that sort of thing would be done, the faster you have an input.
Yeah, because let me just interject. I mean, if you pick your poison, would you rather starve to death in 10 years or choke to death in 20? When you get right down to it.
The chair would be happy to work with Mr. Gingrey in trying to develop something like this. Let me say this has been a modified type of hearing today. I appreciate the staff, our members, and the witnesses for their indulgence. This has been important to our continuing basis of knowledge. We have a vote. I'm afraid that the attendance would be very poor if we tried to come back again, so we will adjourn. And again, thank you for being here.